Let me start the recording. Okay, so we are recording the meeting so that in case you forget something, you can always come back to it. Or if a student want to know what we did, the student may be able to know. Do you want us to go over chapter 7 quickly before doing the homework, or you already know the problems that you have?
No, I would want to go over chapter 7.
Okay. So chapter 7 is about, you can see the PowerPoint, chapter 7 overview.
Yeah.
Okay. So this is about estimating a parameter using a statistic. A statistic is a measure from the sample. So in general, in statistic, we collect data in a sample, and from that sample, we have an information. For example, if we want to estimate the population mean, we will take a sample maybe of 50 individuals, take the average, and use it to estimate a range of values that we call confidence interval for the population mean. So we are going to start with the sample mean, how to estimate the population mean using the sample mean. So we have two cases. The first case is when the standard deviation of the population is known, and the second case is when it is unknown. In both cases, we first compute the margin of error, which is E, and then subtract it from the sample mean, add it to the sample mean to have the lower and upper value of the population mean. So when sigma is known, you have the formula here for the margin of error. Z alpha over 2. What is Z alpha over 2? Z alpha over 2 is the critical point which is obtained by, in general, in the book you will be given. But if you remember in chapter 6, we learn how to find Z so that the area to the left of Z is a certain value, maybe 0.01. So when you have alpha, you divide it by 2. That will be the area to the left of the critical value. You will not need to do this if you have a TI-83 calculator. Do you have one, TI-83 or 84?
It's a Casio, so I'm still not sure how to.
Okay, it will be a little bit more difficult for you to use that, but you can also use Excel. And we are going to learn then how to use Excel. But I will use calculator for those who may want to follow us later. I will also discuss how to use calculator. So as I said, we have two cases. The first case is when sigma is known. The second is when sigma is unknown. So when sigma is known, we will use this formula to compute the margin of error. Sigma is the population standard deviation and n is the sample size. So these are the Z alpha over 2 for the most common confidence level. So for this confidence level, if, for example, the confidence level is 90%, then Z alpha over 2 is 1.65. So this is an example. A researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevrolet iView. A sample of 50 cars had a mean time on the dealer's lot of 54 days. So the sample mean is 54. Assume the population standard deviation of the population is 6 days. Find the best point estimate of the population mean and the 95% confidence interval of the population mean. So the best point estimate of the population mean is the sample mean, which is 54 days. And The confidence level here is 95%. For 95%, Z alpha over 2 is 1.96. So you fit all these values into the formula, and you have 1.96 times 6 over square root of 50, which is 1.4. You can use your calculator to do this computation. With a TI-83 calculator, you really don't need to do all of this single computation. You just need to go to your calculator and press start on your calculator, and you will go to test. And from test, you are going to choose one Z interval, which is 7. For those who are using calculator, you will choose Z interval. Here we have the choice, either we use data or we use statistic, because we are given the statistic, which is the sample mean, the sample size, and the population standard deviation. We will just fit these values into the calculator. The population standard deviation here is 6. The sample mean is 54. The sample size here is 50. The confidence interval is 0.95. And then you calculate. So for us if we are doing it manually, we find E to be 1.7, which we will add to 54 and subtract it to 54 to have the confidence interval is 52.3 to 55.7. For those who are using calculator, they will just see that. The little advantage of the calculator is that you are not going to look for 1.96, multiply by 6 and divide by square root of 50. You put it in the calculator and it does the computation for you. So, another type of question you will have for confidence interval for the mean when sigma is none is to find the sample size. The minimum sample size is the minimum sample size to achieve a certain margin of error. In this type of question, the margin of error is given to you. The standard deviation is given to you. You fit into the formula to find the minimum sample size. Let's look at an example. A scientist wishes to estimate the average depth of a river. He wants to be 99% confident that the estimate is accurate within 2 feet. This means the margin of error is 2. From previous study, the standard deviation of the depth measure was 4.38. So now we are going to remember that for 99%, the Z alpha over 2 is 2.58. So E is 2 and sigma is 4.38. We replace into this formula to get the sample size 31.92, which we will round up to 32. Always round up the minimum sample size. Remember that there is a square here. Sometimes students forget this square. If you have a question, just speak. Any of you, if you have any question, just speak, just stop me. We are just, at this point, we are just 3, so feel free to speak when you have any question if you don't understand. I'm quickly going over the note, then we will work on the homework together.
I have no idea where you are getting the Z, E, or
Z alpha over 2. Is that?
Yeah, I don't know how you're getting that.
The Z alpha over 2 is the critical value. Can you see here? Confidence level 90%, Z is 1.65. 95%, Z is 1.96. 98%, Z is 2.33. 99%, like in this case, Z is 2.58.
So is there a chart in our book that we have to use for this?
Yes, you have a chart, but I selected the most common confidence level. You can either come back to this or you can go to your textbook. If you go to your textbook, I don't think they have not summarized as I did here, but you can always, given, it's a little bit more complicated to use, just use this one for now. Because what you will do, if you have your textbook, you will see a table at the back of your book. On that table, you will find the the cumulative standard normal distribution. So when you have 99%, it means you consider 1%. If you have 95%, you consider 5%. If you have 90%, you consider 10%. You divide that by 2. If alpha is 1, divided by 2 is 0.5. So 0.5% is 0.05. You will go back into that textbook and look for the probability of 0.05, go to the site of the book to identify the Z value that corresponds to 0.05, which you will find to be 2.58. So you may just print this page. It will be useful. Do you have a TI-83 calculator?
No.
Okay, then you will need this table. If you have this table, this is where we are getting the Z. To go and be finding it each time will be, you can get a little mixed up. Just use this table because most of the question we are going to have will have 90%, 95, 98, 99. That is, you want to be 90% confident, 95% confident, 98% confident, 99% confident. Okay?
Yeah, that makes sense.
Okay, so we are going to get to, okay, whenever you see this Z alpha over 2, just think about confidence level. The alpha over 2, we are going to use it much later. Alpha is 1 minus confidence level. So when sigma is unknown, we use the T distribution. There is condition that the population should be normally distributed, or the sample size should be at least 30. So, but we use the T distribution. For this T distribution, we are going to look into that table to find a critical value, T alpha over 2. So be ready to make use of your textbook here because you don't have a TI-83 calculator. And I cannot give you like for the Z. So for the T distribution, the margin of error will be T alpha over 2 times S over square root of N. So let's look at how do we find T alpha over 2. Remember for the Z, we have 90, 1.65, 95, 1.96, 98, 2.33, 99, 2.58. That is for Z. For T, you will need to know the degree of freedom. The degree of freedom is N minus 1 when the sample size is N. The degree of freedom is N minus 1. And you come to this table. If you have your textbook, let's go to the T distribution table. The T distribution table is at the back of your book on appendix. If you go, I will look at the page 652. If you are using the 8th edition, is page 652. If you are using the 7th edition, the table is still page 652. So in page 652, here we want to find T alpha over 2 for 95% confidence interval when the sample size is 22. If the sample size is 22, degree of freedom is N minus 1, so 22 minus 1 is 21. So you are at 21, and you go to confidence interval 95%, you will find T alpha over 2 is 2.08. Are you following me here?
Yeah.
So this is how you find that T alpha over 2. S is the sample standard deviation. For those who have TI-83, you will not need to go through this because you go to start, you go to test, and you choose the T interval. And let's do this example. A randomly selected 10 randomly selected people were asked how long they slept at night. The mean time was 7.1 hours and the standard deviation was 0.78. So this standard deviation is for the sample because it is for 10 individual randomly selected. So the population standard deviation is not given here. Find a 95% confidence interval for the mean time. So the first thing we want to get here is the critical value T alpha over 2. So if you have your textbook, just try with me at this point to go to page 652, table F for the T distribution. Here the sample size is 10, the degree of freedom is n minus 1, so the degree of freedom is 9. The confidence level is 95, so under degree of freedom 9 and 95%, you will see 2.262. 2.262 is the confidence level. The standard deviation is S, which is 0.78. The sample size N is 10. You fit into this equation. Remember, you have to do 7.1 minus the margin of error. The margin of error is this portion, which you can compute separately, subtract it from the sample mean, add it to the sample mean. If you are using a TI-83 calculator, you go to Start, then Test, and choose number 8 T interval, number 8 T interval. As you get there, you will have the choice either data or start. Data is generally when the data values are given. With start, you will enter the values. The mean is 7.1. The sample standard deviation is 0.78. The sample size here is 10. Confidence level is 95. And then we calculate. So here you will have the margin of error is negative 0.56, and the subtracted from 7.1, add it to 7.1, and you will have a confidence interval of 6.5. From the calculator is 6.54. The answers of the calculator and the book are not exactly the same because we keep rounding up when we are doing our computation manually. For those of you who are using calculator, you might see some little difference, but it doesn't really make, it's not an important difference. Always on multiple choice, choose the closest answer to what you have on your calculator. But most of the time, the answers are not so different as to confuse you. So this is how we find the confidence interval when sigma is unknown using the T distribution.
Okay, so looking at the table, I know how you have the 95%, but how did you go, like, which number did you use to find the 2.262?
Okay, are you with the table?
Yeah.
You see confidence intervals, you have 95%. Now the sample size here is 10. The degree of freedom is n minus 1, which is 10 minus 1, 9. So from that 95, go along that column until you reach the row with 9.
Oh, so you have to subtract 1?
Yes, from the sample size.
Okay.
Okay?
Yeah.
Please, always stop me if you don't understand, because sometimes it's just a little thing. Just stop me, don't let me just go, and then you are just lost. We are just 3, as I say, let's make sure we understand what we are doing. Thank you. So this is how you get the T alpha over 2 that you fit into this equation. The sample standard deviation is 0.78. The sample size is 10. You put into the equation and get the confidence interval. So for those who are using calculator, if you are not using calculator, you will have to use Excel here. You will have to use Excel. Do you want to learn how to use Excel by any chance? I do not generally give you this type of questions on exam when I give data, because I am assuming that some people don't have calculator. I may not want to use Excel. But if you want to use Excel, we can use it. Any of you two want to use Excel?
So if I don't learn how to use Excel, like I can still keep using the chart?
No, here you will have to manually do the computation.
Oh, I rather learn Excel.
Yes, what about that? Let's do Excel. Both of you have your laptop?
Yeah, I have my laptop.
Okay, so let's go to the laptop, and it will not take much time. You go to Excel from your laptop. Can you see Excel on the screen?
Yeah.
Okay, so then so do you see both screen, Excel and the PowerPoint?
No, I only see the PowerPoint.
You can only see the PowerPoint. Okay, so let me go to, I want to type let me quickly type the values. I will type the value on column A is 54, 60, 59, 100, 60, 90, 63, 10, 71, 60, 84, 40, 99, 30. So you enter the data value on Excel on column A.
Okay.
Okay for both of you?
Yeah, okay for me.
Okay. Rosalinda, are you okay?
Yeah.
Okay, good. So we now go to data. Follow me. You can see my screen. Do you see data analysis on my screen?
No, I still only see the PowerPoint.
You are seeing the PowerPoint?
Yeah.
Okay. Let me put the PowerPoint down. Can you see Excel now?
No.
Okay, I will bring Excel down.
I can see it now.
Okay, you can see Excel now. Okay, you type the data values in column A on Excel. It's very good to know Excel because you can use it in many places. Calculator, after school, sometimes you don't even know where you keep it. Excel, you can always find it. But there are so much Excel cannot do. But what it can do, we will try as much as possible to be using it for what it can do. Okay, we have the data on Excel. And do you see data analysis here? At the top right corner of Excel. Can you see it on my own screen?
Yeah, I can see it on your screen.
And you cannot see it on yours?
No.
Okay, both of you? Okay, let's put data analysis on your Excel. We are going to follow me to get data analysis. Are you ready?
Yeah.
Okay, you go to File.
Okay.
Then you will see options somewhere here.
Okay.
And a box will come up. So look here, you will see add-ins. You see add-ins. Is that good?
Yeah.
So we click on add-ins. Now you will go below that box. You will see manage Excel add-ins. Click go.
Okay.
Then you will see analysis toolpath. Yours are not checked. You see these first two, analysis toolpath VBA.
Mm-hmm.
Check those first two as on mine.
Okay.
So yours was like this, then you check it and you click OK. So do you have data analysis now?
No. Wait.
No, for both of you?
Oh, wait, yeah, I have it.
Okay, you have data analysis.
Yes.
That's the main tool we are going to be using in chapter 7, 8, 9, and 10. We will be needing this data analysis.
Okay.
You will not lose it if you don't reset your computer. Sometimes you can lose it, but if you lose it, you put off your computer, you put it back, it will come back. So don't worry about losing it. If you lose it and you want me to help you, anyway, if you need help badly, just send me an email and we can organize this, because sometimes I organize a class and nobody show up. So if you want help, we can always have it at least once every week. And if you have a question and I cannot explain by email, I can tell you what time are you free so that we go on Zoom and learn. So we have data analysis here. We are going to click on data analysis.
Okay.
Then you will see descriptive statistic.
Yes.
You see descriptive statistic, then you click OK. Now input range.
Mm-hmm.
On input range, highlight your data values. Or you can type A1 column A2, A7, or you just highlight it as I did.
Okay.
Then I will choose output range here. Look at what happened. When I choose output range, I have to click here so that I to enter the cell where I want my result to be. So which can be here. I just press D3. I could press C3. So now you have here summary statistic. You have to remember to click summary statistic. My aim is for you to get the mean and standard deviation, which takes time to get manually. But remember that we have done so much because we are just starting. All what you needed was put the data on column A, click this data analysis, descriptive statistic, highlight, output, summary statistics. And let's see if we can get the confidence level here for the mean. That question was for 95% confidence. I think it was 95%. 99%. So I'm going to change this 95 to 99. Are we okay?
Yeah.
Then we press OK.
Now, what we just did we like just solve the problem?
Yes. Did we solve the problem? Let me say we find the mean and the standard deviation. Let me check. What is the mean there? Do you see the mean?
Mm-hmm.
What is the mean?
704.
That is the mean. You see the standard deviation.
Yeah, I have the standard deviation.
Okay. you know, to find the confidence interval, what you need essentially is the margin of error E. Do you remember that that's what we are really computing? Maybe you lost track. Let me get back to PowerPoint. You have your result there. I just assume if you got the mean right, then you will be able to, I mean, that everything else will be right. Let's just assume that, because I want us to go back to the PowerPoint.
Okay.
So this is the PowerPoint. Remember, this problem did not provide you with the mean, but it provided you with data values. So Excel gave you the mean and the standard deviation. Now, look at here. Do you see this formula? 7041. Do you see 2256.2?
Yeah.
Okay, I want to show you that where it is on Excel. It is here. Up. You look at the last line of the Excel result. Do you see confidence level? So you see, can you read the number that you have there?
2256.43.
Yes. So that is what you have here, 22.56. Do you understand what I mean?
Yeah.
So that number is the margin of error. So you need to subtract it from the mean to get the final answer. Are we good here?
So we subtracted the mean from the confidence level, and the answer was, what were they looking for in the answer?
Okay, let me quickly go back and so that we know what we are doing. If you are on this PowerPoint, can you see the PowerPoint?
Yeah.
Okay, look at this formula. This is the formula for the confidence interval. It is sample mean minus E, sample mean plus E. Do we see that?
Yeah.
So if we want the confidence interval for the mean, we need to know the sample mean and the margin of error. Is that right?
Yeah.
If we know the sample mean and the margin of error, sometimes I give you that type, a quick question like that on quiz or exam. If the sample mean is this and the margin of error is that, what is the confidence interval? You just do sample mean minus error plus sample mean plus error. The error is the difference between the actual value and the one you have estimated. So if you have the error, you can say, okay, if I say John is 20 years old, I'm wrong by 2 years at most. It means he could be at least 18, at most 22. Do you get what I've just said here?
I think so.
If I am wrong by at most 2 years by estimating John's age at 22, then the least he could be is 18, that is 20 minus 2. The highest it could be is 22, that is 20 plus 2.
Yeah.
That is just the general idea of the margin of error.
Right. But
so if we,
the E stands for confidence level?
Yes.
Okay.
For Excel is not writing it exactly. It stands for the margin of error of the confidence interval.
Okay.
But they use confidence level there because that's what information they will ask you. And what they provide you with on Excel is that E, the margin of error.
Okay.
But a useful information you get from Excel is the sample mean. Because you were given data and you did not have the sample mean. But to find the sample mean, you just add all those values and divide out by the sample size. So now,
what does the U stand for?
That U is the population mean.
Okay.
It's actually mu. is the Greek letter for mu. Is the M for the Greek. You understand?
Yeah.
That U is just, you see, one leg is a little bit more than the other one. So each time you want to find the confidence interval, you need the margin of error and the sample mean. Subtract the margin of error from the sample mean, add it to the sample mean, and you will have the lower and upper values of the confidence interval. A confidence interval has a lower and an upper value. So we are saying that we are 95% confident that the population mean is at least this value, at most that value. So let's get back to our example that we are trying to do. So in this example, the first one, they did not give us data. When they don't give you data, you have to use this formula to find E. When they give you data, like in the second example, now we know what to do because we can use Excel to find the sample mean and the confidence and the margin of error. So Excel will give you sample mean and margin of error. If you practice it with 2 or 3, we will do another homework. So now let's go to, are we okay at this point?
Yeah.
If you are not, let me know, please. Let's not, okay? Please, just let me know, and it will help those who are not with us. When you ask a lot of questions, then we are kind of helping a lot of people. Okay, so we put the values in Excel to get the mean and the margin of error. Subtract the margin of error from the mean, add it to the mean to get the confidence interval, which is 47, 85.2, 92, 97.6.
Okay.
So confidence interval for proportion. This one is also, you are going to use your regular calculator. Excel will not do it. TI-83 calculator can do it. So what we call proportion is the sample size, is the number of success, that is the number that we want, divided by the total. Remember the word proportion. So if we have a class of 10 students, 6 female and 4 male, the proportion of female will be 6/10, that is 0.6 or 60%. That is what we call sample proportion. Is that good for sample proportion?
Yeah, so the sample mean and the sample proportions, like these are two completely different things, right?
Two completely different things. They are two different statistics. We finish with this sample mean. We are now considering proportion, which are all values that are used in statistics. So proportion is simple. You just take the number that is favorable divided by the total.
So the X still is...
Here is not X bar. Remember, here is X. That is the number of success. For example, we might want to know what proportion of the population is sick. So we count the number of people that are sick divided by the total.
So, okay, so like I guess, like the X could be, so the total population is 150. So that's
Yes.
N. And then the part of it that we want to test or something is the 54.
Yes. Look at this example. In a recent survey of 150 households, 54 had central air conditioning.
Okay.
So the proportion of those who have central air conditioning is 54/150.
Okay.
So that is 0.036. So 36% of the sample that we took have central AC. But can we say that the whole population is 36% of them have central AC? No, this is only for the 150 that we have. But this information from the sample, we can try to generalize it to the whole population by computing the confidence interval for the population proportion using the sample proportion. So this is the formula for the margin of error for confidence interval for population proportion. So we will get back to the Z, remember the Z alpha over 2, that slide where you have 90%, 1.65, 95%, 1.96, 98%, 2.33, 99%, 2.58. For proportion, you will need that slide.
Okay.
Which will help you to get this. Whenever you have Z alpha over 2, that slide is going to help you. So alpha over 2 is the area to the left of Z alpha over 2. So then P hat is the sample proportion, and 1 minus P hat is Q hat. Q hat is the opposite. 1 minus P hat is Q hat. So let's look at this example. So a sample of 500 nursing applications includes 60 from men. Find a 90% confidence interval of the true proportion of men who applied to the nursing program. So we have a sample of 500 and we identify 60 men. So what is the confidence interval for the true proportion of men? That's what we would like to do. So here, this P is P hat actually. So I will not correct it now to save time. So P hat is X over N, that's the sample proportion, is 0.12. And Q hat is 0.88. Q hat is just 1 minus P hat.
Oh, Q hat, okay. Q, you said is minus.
1 minus P.
Okay.
So if you look into this formula, what we actually need is P hat, which is 0.12, Z alpha over 2. We go back to that slide. You don't need to go, I know it's 1.65, and you will have 1.65 here. Now you do square root, P hat again, 0.12, Q hat 0.88, N is 500. So that is what you fit into the formula that we have here.
Okay.
And you will carefully do the computation. I advise that you do step by step. 0.12 times 0.88, get the answer, divide it by 500, write the answer down, take the square root, and multiply by 1.65, and you get 0.024. This 0.024, you subtract it from 0.12, add it to 0.12, and the true proportion is 0.096 to 0.144.
Okay.
Okay, now I'm speaking for those who are listening to us, those who have TI-83 calculator. You go to your calculator and press start again. Start, go to test, and you will go down to 1 proportion Z test. After 0, you will see 1 proportion Z interval. I'm sorry, 1 proportion Z interval. You press OK, and then you will enter X here is 60, N here is 500. The confidence interval here is 0.9. Then you calculate, and you will have 0.096 to 0.144. So when you are using calculator, that's what you will do. But it's good for you to learn this algebra that we are doing here. But if you had a TI-83 calculator, you will not know the algebra, but you will get the answer. So the interpretation is that we are 90% confident that the percentage of applicants who are men is between 9.6 and 14.4%. So for sample proportion also, we can compute the minimum sample size. So to compute the minimum sample size, we don't really need this P hat and Q hat, but to compute the minimum sample size, we have two options. One, when there is an estimate of the population proportion, and the other one where there is no estimate. A researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. That is, the researcher does not want to be wrong by more than 2%. So here our margin of error is 2%, which is 0.02. So we will fit into this formula. E is 0.02. Z alpha over 2 for 95% is 1.96. So we do 1.96 divided by 0.02 square, multiply by P, multiply by Q, and we'll get 2304.96. We round it up to 2305. This is the minimum sample size so that the answer you get should not be wrong by more than 2%. For example, now that you are hearing about election, they might tell you that a candidate poll is 44%, another candidate maybe is 40%. You might want to know, did they choose a sample large enough to have a margin of error of less than 5? Because if the margin of error is not less than 5, then there's no difference between 40% and 44%. That's the essence of the confidence interval. It helps you to actually picture what is the real result. That is why sometimes you will see polls might indicate that somebody is doing better, but later it doesn't work. Because no one really cares about the sample size that was used to compute that sample proportion, which is used for polls. What is the margin of error? If you are not told, you cannot interpret a sample proportion correctly. To interpret the sample proportion correctly, you compute the confidence interval. In this example, somebody might want to say, if you want me to trust your polls, I want you to have the minimum sample size that will guarantee that the difference between your poll and the actual result is not more than 2%. If you tell them like that, they might want to get a sample size of maybe 5 million people before they achieve that. So minimum sample size helps us to determine a confidence interval that we are kind of sure to understand the meaning of it fully. So the formula is here. Now, sometimes you want this confidence interval and you don't have an estimate of the population proportion. If you don't have an estimate of the population proportion, just use 50%. You see that with an estimate, we have a better result than when you don't have an estimate. When you don't have an estimate, you take 50%. Now, we are getting to a little more difficult concept, which is actually the last one, confidence interval for variance and standard deviation. I hope we will have time to quickly go over homework. Anybody want us to stop at this point and go to homework? Because you can always go over this one on your own, but if you have time, I will not mind to add another 30 minutes. I can still stay with you to go over all the homework. But I don't want you to feel compelled to stay all the time and be feeling maybe not happy. Okay, please let.
I definitely would want to go over at least the first section of the homework.
You want us to go over the section 1, 2, and 3?
I like at least one.
At least one.
I mean, will the chi-square distributions, will those be on the quiz?
It will be on the quiz of chapter 7, yes.
Okay.
Okay, let's add 5 minutes. At 25, we go on homework. What about that? Whether we finish or not.
Okay.
So that you have an idea of what the chi-square, we call it chi-square distribution.
Oh.
So The chi-square distribution is a positive distribution. It is skewed to the right. It depends on degree of freedom like the T distribution. So this is how you find the confidence interval for the variance. You take the sample variance or the square of the standard deviation times the degree of freedom divided by chi-square right and then divided by chi-square left. So what is important to know here is how to find chi-square right and chi-square left. And you will have those questions on the quiz. Let's look at an example, how to find chi-square right and chi-square left. Table, remember that table in page 652?
What page?
652.
Oh, yeah.
T distribution. Now we want to go to 653. Page 653.
You 653.
Have you seen chi-square distribution table?
I'm still scrolling.
Page 653.
Okay, I have it.
You all have it? So
yeah.
We want to find chi-square right and chi-square left for a 95% confidence interval when n equals to 25. For 90%, alpha is 10%. Remember that. Alpha is 1 minus confidence level. So that 10%, you divide it by 2 because we want alpha over 2. When I'm teaching in class, because in your textbook you have right and left, I use alpha over 2 and 1 minus alpha over 2. So alpha over 2 here is 0.05. That is 5%. Do we understand what I'm saying here?
No.
Okay, let me explain differently. Hope you see 90%. What is the middle between 90% and 100? Can somebody tell me? Between 90 and 100, the middle is at 95.
Yeah.
It's just like dividing the 10 is the distance is 10 between 90 and 100. The distance is 10. So if you divide that 10 by 5, you will have 5 and 95.
Okay.
Do we understand that idea?
Yeah. So you're just dividing it in half.
You just divide the remaining part by half, and then you will have that half, that 10 you divide by half, that gives you 5%, and then you subtract it from 100 and you have 95%. Those two numbers are what we will need, 5 and 95. For 95, the percentage is 0.95, but for 5, the percentage is 0.05. Do we understand this?
Yeah.
Hey, that yeah is not very good. Look, we have 90, right? 90%. 90% correspond to 0.9. Do we know that?
Yeah.
Okay. So you will, from 90% to 100 is 10%. If you divide that by 2, you will have 5%. So 5% is like divide 5 by 100 is 0.05.
Yeah.
And 1 minus 0.05 is 0.95.
Yeah.
That is the work to do with chi-square distribution to get those two numbers. 0.05 is the half of what will complete it to make 100. Subtract it from 100 to get 0.95.
So we're trying to get two numbers?
We will need two numbers. Remember, we have left and right. Chi-square right and chi-square left. Are you getting me?
Yeah.
find the chi-square right and chi-square left. For chi-square right, we will need, just 1 minute. For chi-square right, we will need 0.05, which is at the right of the table. For chi-square left, we will need 0.95, which is at the left side of the table. Now hold the table and you will see what I'm talking about. Do you see alpha on the table?
Yeah.
You see that alpha. So on the right of alpha, you have 0.05. You can identify 0.05. Just below alpha, you will see 0.01, 0.05. Do you see that?
Yeah.
So n is 25. So degree of freedom is 24. So you go below that 0.05 to find the number corresponding to chi-square right. Assuming that you knew what this process is from the T distribution, I want you to understand now where the 0.05 and the 0.95 are coming from again. Because the confidence level is 90%, you want to go halfway to 100 by dividing the 10 by 2, and that is 5. Minus 100, 100 minus 5 is 95. So now you have 95% and 5%. 5% is to the right and 95% is to the left. So find the chi-square left, you go below 0.95 to degree of freedom of 24. Can you tell me what you see? What number do you see? Under 0.95, degree of freedom of 24.
13.848.
13.848. You can see on the PowerPoint, that is the chi-square left. It's at the left of alpha. Now, you go to the right of alpha, the right is at 0.05.
Mm-hmm.
You get 36.415. Okay?
Okay.
So just come back to this. We are recording all what we are doing so that you can come back to it later when I upload it on Canvas. So sometimes we may have, if we have a 95% confidence interval, then the balance is 5%. You divide it by 2, you have 2.5. So the left will be 0.025 and the right will be 0.0975. Remember, degree of freedom is n minus 1. That's the next slide. So to find the confidence interval for variance, you need to know what is the chi-square right and chi-square left, the sample variance, the degree of freedom, and then you will get the confidence interval for the variance. To have the confidence interval for standard deviation, you take the square root of the two numbers, and you have the confidence interval for the standard deviation. Okay, so we will quickly go over at least 7.1 as you said. And if you want, homework are due on Wednesday. Because of your patience, I will be willing to come back on it with you if you want, either tomorrow or on Tuesday. But let's see what we can do. Do you want us to go over the homework now, or it's 7:30?
Yeah.
We should go over. Okay. Okay, page 371.
Which page?
Page 370. What is this? It's like these pages. Oh yeah, page 371. Yes, 371.
Yeah.
Number 9. Since 1975, the average fuel efficiency of US cars and light truck has increased from 13.5 to 25.8, an increase of 90%. A random sample of 40 cars from a large community got a mean mileage of 28.1 mile per vehicle. So we have this, the mean, 28.1. The population standard deviation is 4.7. Estimate the true mean gas mileage with 95% confidence. So 95% confidence, the Z alpha over 2 is 1.96. Z alpha over 2 is 1.96 for 95%. So we want to multiply it by the standard deviation, which is 4.7. And we divide it by square root of, what is the sample size?
What formula are we using?
Are you seeing the, can you see the screen?
Oh,
So we are using the Z, the formula when sigma is none, with the Z alpha over 2. Do you see the formula?
yeah.
So now you want to write the sample mean here is 28.1. So the formula is 28.1 minus 1.96 times standard deviation is 4.7 divided by square root of 40. If you like, you first do square root of 40 alone. And the square root of 40 is 6.32. Then you do standard deviation is 4.7 divided by 6.32. Are you good?
I'm still writing it down. The mean, the X is 28.1.
Yeah, X is 28.1. Z alpha over 2 is 1.96. Sigma is 4.7. N is 40.
So sigma just stands for standard deviation.
Yes, for the population standard deviation. For sample, it is S. Are you getting somewhere?
Sorry?
Are you getting a result?
I just wrote down the whole formula.
You wrote down the whole formula.
Yeah.
So I will advise you to do sigma over square root of n alone. Maybe write right? 28.1 minus 1.96, and then you have it down. But instead of writing sigma over square root of n, just do that computation, which is 4.7 over square root of 40. I don't know how your calculator is, but I prefer when you have simple calculator that you do gradually so that you don't make mistake.
The 4.7 over the square root of 40, does that equal 0.74?
Yes.
Okay.
Then multiply it by 1.96.
Oh.
Hold on. I think, yeah, you have, yes, you are right. Multiply by 1.96.
But I did the 28.1 minus 1.96 first, and then I got 26.
No, you will be doing it wrongly. If you do that, you are not following the procedure of the rule of algebra. You have to do 1.96 times 4.7 divided by square root of 40. You see the 0.7431? That you have to multiply that by 1.96. You do square root and multiplication before addition and subtraction.
Okay.
Do you understand what I mean?
Yeah.
Okay. Then you will get 1.46 or 1.456.
I just got 1.45.
Yes. Then you do 28.1 minus 1.45.
26.65.
Yes. That's the right answer. So you remember this 1.45? You don't need to do all of this computation again. Just add again 28.1 plus 1.45.
$29.55.
Yes. And so I will skip 11. It's exactly the same type of work that you will do for 11.
So for number 9, do we need both of the answers?
The two answers you have is this lower one and the upper one. The confidence interval has two numbers. Remember?
Okay, so both of those numbers are the correct answer.
Yeah, the correct answer, it's not like both are the correct answer. The correct answer is 26.6 to 29.55 or 29.6. Interval has two numbers.
Okay.
The smaller one is 26.6 and the bigger one is 29.6. Do you understand?
Yeah.
You have to write 26.6 is less than mu, that's what you were calling u, less than 29.6. Just round it up to 29.6.
Okay.
So if you can follow this, you will be able to do all the homework of this section, maybe except 23. We can do 23 together. The other ones are similar, that's why I'm skipping. You will need to find z alpha over 2, divide the standard deviation by the square root of the sample size, multiply by z alpha over 2, and then subtract it from the mean, add it to the mean. That's why I like you to do that E first. Z alpha over 2 times sigma over square root of n, add and subtract to get the two numbers. Now on number 23, A researcher wishes to estimate the average number of minutes per day a person spends on the internet. How large a sample must she select if she wishes to be 90% confident that the population mean is within 10 minutes of the sample mean? Assume the population standard deviation is 42 minutes. So if they say it's within 10 minutes, it means the margin of error is 10. We are using this formula. So confidence level here is 90%, and Z alpha over 2 is 1.65. Standard deviation is 42. So you will do 1.65 divided by, multiplied by 42. 1.65 times 42. I'm sorry, 1.65 times 42 divided by 10.
Wait, what are the numbers again?
Do you see the formula on the screen?
Yeah, I see the formula.
Z alpha over 2 is 1.65.
Okay.
Multiply it by sigma, which is the population standard deviation, and here it is 42.
Okay.
Then divide what you get by 10.
Why 10?
Because the margin of error E is 10.
Oh, okay.
Okay.
And we're looking for n, so we don't know what n is.
Yeah, so what answer do you get there? 1.65 times 42 divided by 10.
And then I have to square it, right?
Yes.
48.02.
So you round it up, always round it up to 49. N is a natural number, so it is a whole number. Always round it up.
Okay. So that is the answer?
Mm-hmm.
Oh, that one was easier than the previous formula.
Yeah, that one was easier. You want us to do one more? As I say, if you have time tomorrow or on Tuesday, just let me know. Any of two of you. If you want, I can meet you again. Because if you feel like you need help, I can continue, but I know you might be tired. So but if you want, we can do one more, just as you wish. I am at home, so.
I mean, I just wanted to know if these, the only one I still don't understand is chi. Like, I really don't understand that one still, but the other ones I think I could figure out if they apply to a lot of the problems, I think I could get it.
Yeah, the chi know that you need 2 confidence level. They give you a confidence level, you divide it into 2 by going midway to 100 from what they give you. If they give you 90, you have 5 and 95. If they give you 95, you have 2.5 and 97.5. If you can think well of what I am doing, and they give you 95, you go middle. You take the 5 remaining, divide by 2, you have 2.5. You add it to 95, you get 97.5 and 2.5. Make it into percentage. Think about degree of freedom, n minus 1. And you will get the chi-square right and the chi-square left.
Okay. So we go over like number 5 on 379.
Page 379.
Yeah.
Okay. A random sample of 15 registered nurses in a large hospital showed that they work an average of 44.2. So just write X bar equals to 44.2 per week. Average X bar.
How do I know which formula to use?
Okay, how do you know which formula to use? Let me read the whole problem, then I will tell you. The standard deviation of the sample was 2.6. Do you see this information? The
Yeah.
standard deviation of the sample was 2.6. This
Yeah.
means they have not given you the standard deviation of the population. So sigma is unknown. Do you understand?
Yeah.
The standard deviation of the population sigma is not given. So you will use the formula which is on your screen. For that formula, you need S. Can you tell me what S is? The standard deviation of the sample, if you look at number 5. S is the sample standard deviation. Do you know what it is?
2.6.
The 2.6. Do you know what X bar is?
The 15.
No.
No.
X bar is the sample mean, the average.
44.2.
44.2. 15 is the sample size.
So the X is the 44.2.
S is 2.6. N is 15. What you don't know is T alpha over 2.
What was N?
N, sample size.
Oh, samples.
15.
15. And what about that T?
That T is what we will go to page 652 to get.
Okay.
Remember page 652?
Mm-hmm.
So do you see the confidence level? It was 90.
Yeah.
Confidence level was 90. So we will be at 90%. Sample size was 15. So the degree of freedom is 14. Always remember that. You have to subtract from 1.
So 1.761.
1.761. So I always prefer that you do this computation first. 1.7, I don't remember again. 1. What? Anyway, did you write it down? I closed the book.
1.761.
Okay. Yes, you do that, multiply by the standard deviation 2.6 divided by square root of n. Get that number.
Okay.
And then subtract it from the mean, add it to the mean.
So I have to subtract it and add it.
Mm-hmm. What do you get?
I got 43 or 44, I guess, and then 45.9.
Let me do it again. You had 2.6 times 1.716 divided by square root of 15. Okay. Minus 44.2. You should get 43.
Yeah.
The lower value is 43, is that right?
Yes.
And then the upper value 45.
Yes.
That's good.
Okay. So is 7 and number 11 using the same formula?
Number 11. Yes.
7 and 11?
7, you don't need the formula because you have data. You will use Excel for 7.
Okay.
Remember how we use Excel?
Yeah.
And Excel will give you the E that we are computing by doing T alpha over 2 times S over square root of N. That is the confidence level when you are doing Excel. You enter this value on Excel, follow as we did before, and when you at the bottom part, you will see confidence. Remember to change the confidence level. It's
Okay.
generally by default 95 on Excel.
Okay.
And click on confidence level when you are doing Excel.
All right. I think I'm good. For those two sections, I'm pretty good.
Okay. You know, you have 3 attempts for the quiz.
Yeah.
If you take the first attempt and you see you are not doing good, let me know if you want us to meet again.
Okay.
Okay? Any other question?
No, but I'll probably have more tomorrow.
Tomorrow, since we are 3 here, can we agree on a time if we have to meet tomorrow?
I would only be able to meet on Tuesday.
Okay, Tuesday. Can we make it Tuesday instead?
Yeah.
Is it good for both of you?
I'll email you a time on Tuesday.
So email both of us. Anyway, I just want us to be sure that both of us, 3 of us, can be able to meet.
Yeah.
Okay, so just let me know if any time in the afternoon will be, even evening. I just need to know ahead of time.
Yeah.
Okay, if you can email me by tomorrow night, that would be great.
Okay, I can do that.
Okay, so are we good for tonight?
Yeah.
Okay, thank you very much, Kirsp. This is going to help a lot of students, those who don't have time, did not have time to come.
Okay. Yeah.
Mhm.